Hi everyone! Today we are going to present about carboxylic acid in organic chemistry. Let me introduce my group members. Me, Hanis Shahira, Fatin Farzana, and Nur Fatiha Sofia. Do you guys know what carboxylic acid is? Carboxylic acid is an important class of organic compound that contains a carboxyl functional group, which is COOH. This group is made up of carbon atom double bonded to an oxygen atom C double bond O and to a hydroxyl group OH. The presence of this group gives carboxylic acid their acidic character. First, carboxylic acid are considered as weak acid because they partially dissociate in water to release H+ ions, meaning that not all molecules release hydrogen ions into the solution. This causes lower concentration of hydrogen ions in solution compared to strong acid. Second, it can form strong hydrogen bond with water and gives them relatively high boiling points. Third, in the carboxylic acid group, carbon is attached to a highly electronegative oxygen, making the bond polar. Lastly, structure that has carboxylic acid ends in anoic acid. Example of carboxylic acid in a structure we got is formic acid. It was first isolated from ants. It's a very simple carboxylic acid. Its primary role in nature is as a defensive compound. When you get stung by an ant or a bee, the burning sensation you feel is partly due to the formic acid injected. Next is acetic acid. It's the main component that gives vinegar its characteristic sour taste and pungent smell. Moving to a slightly more complex structure, we have benzoic acid. This one is an aromatic carboxylic acid, meaning it contains a benzene ring. Its most common application is as a food preservative. Finally, lactic acid is another common carboxylic acid. It's produced when bacteria ferment lactose.
Now, let's talk about the physical properties of carboxylic acid. First, we have odor. Methanoic acid have an overpowering smell. Second, ethanoic and propanoic acid have a sour and acidic sense. Third, 4 to 8 number of carbon for carboxylic acid have an unpleasant odor of rancid butter. Next, we have boiling point. Boiling point for carboxylic acid increase as the relative molecular mass increase. Moreover, we have solubility. Solubility for carboxylic acid increase as the relative molecular mass decrease. Last but not least, let's talk about the acidity. Carboxylic acid are a stronger acid than alcohol and phenol. This is due to the negative inductive effect and resonant effect on the carbonyl group. Now, let's talk about the effect of substituent group on the acidity of carboxylic acid. First, electron withdrawing group will increase acidity. Second, acid strength increase as the number of halogen increase. Third, electron donating group will decrease acidity. And last, the closer the halogen is to the carbonyl group, the stronger the acid becomes. Now, let's talk about the reaction of carboxylic acid and benzoic acid. First, we have salt formation. Salt formation is divided into two, which is 1. Neutralization and 2. Reaction with electropositive metals. For neutralization, carboxylic acid will react with bases to form carboxylate salt and water. For benzoic acid, it will react with bases 2 to form benzoate salt and water. For reaction with electropositive metal, carboxylic acid will react with reactive metal to form hydrogen gas and carboxylate salt. Next, we have reduction to alcohol. Carboxylic acid and benzoic acid have the same reduction agent, which is lithium aluminium hydride in dry atom. Carboxylic acid will be reduced to form a primary alcohol, while benzoic acid will be reduced to form phenylmethanol. Now, let's move on to the formation of acyl chloride or acid chloride. Carboxylic acid will react with either phosphorus chloride or sulfur dichloride oxide or phosphorus trichloride at room temperature to form acid chloride. For benzoic acid, the mixture must be heated for the reaction to occur. Next, we have formation of ester. Carboxylic acid is heated with an alcohol in the presence of concentrated sulfuric acid to form an ester. Next, we have formation of anhydride. Carboxylic acid is heated with phosphorus pentoxide to form an anhydride. Anhydride also can be formed when a sodium carboxylate reacts with acid chloride. Last but not least, we have formation of amides. Carboxylic acid is heated in the presence of ferric acid to form a primary amide.
In general, carboxylic acids are used in industry like food, cosmetic, pharmaceutical, cleaning products, and chemical manufacturing. Let's take a closer look at each of these. Now, let's explore how carboxylic acids are used in our daily lives. As we can see, carboxylic acids are not just important in science, they are present in many things we use every day. In conclusion, carboxylic acids are one of the most important groups in organic compounds in both chemistry and daily life. Thanks to their carboxyl functional group, they show unique chemical properties like acidity and hydrogen bondings. These properties allow them to be reactive in various organic reactions. Their usefulness can be seen in simple items like vinegar and citrus fruits, all the way to the complex uses in pharmaceutical and chemical industry. By understanding their structures, properties, and uses, we can truly appreciate how carboxylic acids help connect science with real-life benefits. Thank you for watching!